All right. Welcome, everybody, to today's virtual live event. We are kicking off to talk about getting inside Red Canary's human-led AI-powered SOC. Super excited to do that. By way of introductions, first, I am Brian Beyer. I'm the president and co-founder of the Red Canary team here. I have Jimmy Assel with me today, who leads all of our machine learning and AI work. And then you're going to get to meet a bunch of the AI agents that Red Canary is using inside of our SOC. So, first, I want to orient you as we talk about lessons that we've learned using AI agents in our SOC. I want to orient you with why we do all of this because this mission sort of overarches and guides everything that we do. We have this really big mission, which is all about keeping your organizations focused on your mission without being distracted by a cyber attack. That's the overarching goal of everything that the Red Canary team does, all of our products and services. They're all focused on that goal, keeping you focused on your mission, stopping that cyber attack. So if we look at what our SOC has to do, our SOC, your SOC, one of the ways that I often think about it is from a capacity perspective. And if you look at that, you can think of the typical SOC workflow as I wake up in the morning, I have a bunch of alerts and notifications of potentially threatening things that I have to get through. And in order to get through it, I need to put those things in priority order. And then I have some amount of capacity of how many I can get through. So maybe 20 new alerts show up in the day. Maybe based on how much capacity I have, I can get through 10 of those. Hopefully, I deal with the 10 most important ones first. And then when I go to bed, I have 10 more alerts left in my queue that I wasn't able to get through. Well, that's a problem, and it sucks because they keep stacking up, and no matter how hard you try, you always feel like you're falling farther and farther behind. Monday, Tuesday, by the time you get to Friday or the weekend, you have all of this crud sitting in the bottom of your queue that you weren't able to get through. And so our goal in the SOC is how do I get more capacity? How do I get through more of those so I have less alerts sitting inside of there so that I can spend more of my time on more valuable things? That's our goal. And so if we think about what our SOC is actually doing as a process, I have this really, let's say it's a very nice diagram that looks really simple and straightforward of what we actually know is actually a really messy process, but it exists here for illustrative purposes. So imagine all these red dots on the left. These are the alerts that I have to get through as a part of my daily chores here. And so each one of those come in, and then I have two different things I need to do. Sometimes I need to run these processes. I got this alert. I need to go look up the IP addresses or the domain names or other behavior coming from it. And then in other cases, I have to make decisions. I have to my little brain icons here. Do I go deeper? Do I pull data from other data sources? And so I have to work through all of these processes also that I can come to this conclusion of is this alert or is this input benign, suspicious, malicious, or whatever the outcome is. And so if I think about this from a capacity modeling perspective, what I would look at is I would say, okay, let's say it takes me 5 minutes in this example to do each one of these processes, and it takes another 5 minutes to make one of these decisions. And so in my example here, if I have three members in my SOC and they can each spend 360 minutes socking every day, like doing that work, if it takes 5 minutes for me to do each one of these decisions or processes, that means I can get through about 27 of those inputs for the entire SOC each day. So that's the capacity that I have of my SOC, given my team, given the processes and decisions I need to make, and given the inputs. So that's obviously a challenge because, like we talked about earlier, I'm not getting through everything I need every single day. So how do I get more capacity? Well, all of the automation that we brought into our SOCs over the last decade or so has really helped us run a lot of these processes faster. So now, because I've used software and I've used automation and I've used SOAR products and other things to do some of that work for me, you can see that my green processes here, I don't have to spend 5 minutes of human time on those anymore. I can just have software go do them for me. And so I now only need the human in my SOC to make a decision in a couple cases. And so now if we look at our SOC capacity model, what you'll see is my three SOC members still spending 360 minutes per day on the SOC because they have less decisions that they need to make and less processes they need to be a part of. Now that automation has allowed us to make 72 inputs that we can get through each day. So that's a big increase in SOC capacity. So now here's where AI comes in. With AI, with this agentic technology and these LLMs, what it can do is it actually brings in more automation to enable non-humans to make some of these expert decisions. Our little brain icons there. And so now if I look at my SOC, for each of these inputs that's coming in, maybe I only need to make the final decision. I let software run these processes for us. I let AI make some of the earlier decisions, all culminating in a human looking at all of this work that was all pulled together, packaged up nicely with some recommendations, and make the final decision of what I do. And so in that case, look at what happens to our SOC capacity model. Our three SOC members, our 360 minutes of SOCing, now we're able to get through 216 inputs every single day. So that's a huge capacity increase. That's all possible because of this mixture of automation as well as agentic technology. And so Red Canary runs a SOC, just like you all do. And we have a bunch of experts and this huge team of people who are working in that, working on automation, all of that. And so when we ask them, hey, what difference does this agentic technology we're using make for them? One of our detection engineers said, hey, because of these agents, we are able to investigate 10 times more investigative leads. So that's huge. So they get to spend a lot more time looking at novel threats, looking at unusual behaviors, and less of the boring, rote, typical triage and that type of work that causes the SOC to burn out. And so this is great, not just because we are able to get more capacity, but also because we're able to retain the best people for longer because they're doing more interesting work. All right, so let me show you what this looks like in a real example, and then we'll talk about what our lessons learned have been. So one of the processes that we have is we do reviews of emails that were reported by users as potential phishes. It's part of this managed phishing response product we have, and we get these suspicious emails that get reported by our customers and users, and then we have to conclude, is this actually a phish or is it not a phish? And so that's a process where you can see the initial analysis, a bunch of the initial work that comes in is all handled by one of our AI agents. It's going to analyze headers. It's going to look at the subject, the body, look for tone, look for is it pressuring the user to make a decision. It's going to go do that investigation of IPs and URLs, and then it's going to take the attachments, it's going to render them, it's going to look for anything weird. All of those processes and those decisions all get made by that triage agent. And then it produces an assessment and it produces a bunch of features and information. And then that's where the humans get involved. And so our SOC team there is grabbing this agent assessment, looking at the email, doing a final review of some things, and then making a decision, is this a phish or is it not a phish? And so this is an example of how you can have agents and your SOC team working hand in hand to work inside your SOC. And so here's an example of what that can look like. This is actually a really neat product for us because it's the first product to be built agent first. So you can see both what the Red Canary human was doing as well as what the Red Canary agent was doing. You can see the phishing triage agent here in this case said, this is not a phish. Here's why. Here are some suspicious things that it identified when it did that analysis. All of that comes together so the Red Canary team can make a good decision there. All right, so hopefully that was helpful, understanding how we think about the SOC from a capacity perspective, where AI can be helpful. Hopefully the example of what this looks like in real life gives you a sense of where you might be able to apply this. Here are my objectives for the rest of this talk. Want to walk through and I want to empower you with knowledge to transform your SOC. I want to give you some examples of how we're using this technology because I always think it is easier to start with something that somebody else has already done, and I get some of my best ideas hearing from other people's great ideas. And then you have a million vendors who are pitching you some new AI enabled or AI first technology. I want you to have the ability to ask the right questions to be able to evaluate that tech correctly and figure out what makes sense for you. So that's my goal for today. So after 18 to 24 months of using AI agents and this technology inside the Red Canary systems and SOC, here are the six top recommendations that we have. First is when you have your agents, give them a role, formalize it, give them a title, give them a job, treat them like you would treat a specialized resource on your team. One of the things we know is that people perform best and they're most successful when they clearly know what's expected of them. The same thing is true with your agents. Give them a backstory, give them clarity about what you're expecting of them. It makes it really easy to describe what that agent's job is when you talk to other people in the system or when you draw it out on a diagram. It helps you keep your agents focused, prevents them from feature creep and saying, hey, can this agent do these 10 other things for me? And you can say, no, it has its job. If we need to do those other jobs, let's go make some new agents for it. So that sort of personification makes the agents really easy to work with. So that's recommendation number one. Then recommendation number two actually has little to do with your agents. It has to do with knowing yourself and what your system and workflow does. It's going to be really important as you bring AI agents into your SOC that you have well understood workflows and processes. You want to know when these different types of alerts or inputs come in or these tasks have to be done. How do you do that investigation? What other data sources do you use? Do you have consistency in how that's done? You really want to map that out as best you can. We're really fortunate at Red Canary that this is all that we do. And so we have an entire team of people who actually map this out. And I have tons of these processes and flowcharts, like you can see on this slide here, that describe how do we do analysis. That's really important for you to have. You want to know who are the stakeholders, what are the checklists when those exist. Like that's all really important for you to understand about your current processes. And the reason for that is because you're going to use it later. You're going to then look at those processes and you're going to say, okay, which of these jobs do I want agents to start helping me with? You want to keep those agents simple. You're not trying to build the one agent that is the be all end all for your SOC. You're not trying to replace a human who can do 1,000 different things. You want your agents to be simple. You want more of these agents, each focused on a specific task. Here's a little snippet of some of the agents we use inside Red Canary. You can see I have a bunch of identity investigations that are different. Each of those agents are different when they do an agent investigation. They're different based on the platform they work with. Some of them are specialized when we get alerts from CrowdStrike, some Entra, some Duo. All of them are unique. They may share 70 to 80% of the same investigation workflow inside the agent, but there are specializations based on that data that comes in and other data you need to pull together. So that's the third recommendation. Keep your agents simple. Don't create the blob where you're trying to have one agent do everything for you. All right. So now that we have our agents that have a specific role, now that we know our own processes, now that we're thinking about where do I simply want to plug in these specialized agents, then we take our agent and you take all that knowledge and you embed in a standard operating procedure. This is where you actually get to the guts of the agent and you tell it, this is what your job is. This is how I want you to do your job, right? So my identity investigation agent, as an example here, its job, like we had in recommendation one, is to identify suspicious identity activity by triaging and investigating alerts and relevant log and intelligence data. But now here's the standard operating procedure. Agent, I want you to do these 5 steps. I want you to go pull user IP data. I want you to analyze login attempts and MFA status. I want you to assess where that connection is coming from, look for any anomalies. I want you to look at the device the connection is coming from. Is it compliant with our latest security controls or policies? And then I want you to look at all of this against historical baselines, right? So that's the standard operating procedure that a Red Canary detection engineer would do during an investigation. So I'm going to take that same expert standard operating procedure and I'm going to embed it into my agent. That then helps us guide the agent about what great looks like. All of these things, they get stored in version control. You keep track of them over time, and then you can actually evolve those as your standard operating procedures evolve. So that's that next recommendation. Take your standard operating procedures, embed them into your agents, then put them into production. But don't just turn the keys to the kingdom over to them. Put them on probation, just like you would a new member of your team. It's like a new hire. They come in, you're not going to let your new hire go make business critical assessment decisions on day one. You're going to ease them into it. You're going to let them sit there beside a more experienced member of your team, and you're going to double check their work. So that's the same thing you do with your agents. We actually rate a bunch of the agents we have inside of the Red Canary system as what experience level do they have. Kind of keep track of how many repetitions do they have, how much training data was fed into them. We look at what those results are. And so what we're actually going to do in our system is we'll measure the decisions that they're making compared to similar decisions that a human is making. And then we see how close they are. That's what's called alignment. Is the agent aligned with what the human would have decided? And so keep in mind, these agents are software. They can make mistakes. Also, humans can make mistakes. And so what we're looking for is alignment so that we figure out how much do we trust this agent and when are we ready to put it into the next step where it can make more decisions by itself. All right. So now our agents are in production. They're out there, they're in probation. They're out there making those decisions. Now, how do we superpower them? Well, what we do is we keep improving them. We give them feedback, right? Just like another member of your team. How do I continuously give feedback and training back to my agents? Well, one of the things I'm going to do is I'm going to take that alignment data, I'm going to take those examples of when humans made great decisions or even when agents made great decisions, and I'm going to feed that back into the agent and say, hey, I asked you to make a intelligence assessment like this. Here are 5 examples of what a great intelligence assessment looks like. Here are 5 examples of things I don't want you to do, right? And so you can feed some discrete examples back into the agents. The other thing you can do is try and record some training data. This is an area where Red Canary has this super unique position we're in, where for 12 years we've been making millions of assessments. Done so many of these investigations. Every part of that process throws off training data. And so when we build new agents, we just feed all that training data in to say, here are the types of decisions we've made in the past based on input data. And it really helps these agents become effective. You can do the exact same thing with whatever task you're giving to your agents as well, too. And so those are the 6 recommendations. Personify the agents, give them a job, know your system and workflow so that you can embed that system and workflow as standard operating procedures into your agents, which you're going to keep simple. You're going to start them on probation, and then you're going to keep making them better with more feedback and more training data over time. All right. So with those 6 recommendations, now I want to talk about 3 traps to avoid. The first one of them is you don't want to make the blob. Right? It's typical and very natural anytime we build any sort of software system that we build complex things. We just keep bolting on more features, more capabilities. We say, well, I already did the work to make that agent. Wouldn't it be nice if it could do just one more job for me? Oh, I don't really want to go through the process of making something new. Let's just skip the deployment of a new agent and let's just keep adding on to it. You don't want to do that. It creates this blob that's a monolith over time. It's really hard to reuse. It's really hard to test. Not good. So don't do that. So really, like we talked about, keep your agents simple. Give them one job, one task to do, and that's it. Build those boundaries. Second trap to avoid is don't use AI for everything. There are some jobs that AI and LLMs are really, really good for. Things like reading and inferring any sort of unstructured text. Similarly with text, if you need to produce or summarize any text, AI is really good for that. If you're trying to make decisions that are non-deterministic, so think of that as if I can't write a 10-line if statement because I need some more fuzzy logic involved in making a decision, AI is great for that. It's also great for translation if I need to deal with multiple languages. Now, on the other hand, What are things that software is really good for that you don't need AI for? Parsing. If you're getting structured logs coming in from your web servers or any systems, don't spend the time having an AI parse those things for you. It's going to be expensive and it's going to be error prone. Just use normal software. If you need to produce outputs in a simpler template, then in a similar format or anything consistent like that, use normal software for that. Anytime you have a predictable workflow, hey, I have this type of process embedded in my SOAR about how do I go collect other data, and bring it all together using my systems. Those are oftentimes cases where you want to keep that in a very deterministic system and use AI in other places. And then I always like to joke, I think we're going to spend a tremendous amount of electricity in the future having AI do the equivalent of 2 plus 2. We don't need AI for that. Software is much faster and cheaper to do that type of math for us. All right. Third trap, be careful. Really think about when you build these agents and you build these models, what type of data you're loading in with them. Not going to spend a huge amount of time here. Each one of these five principles could be its own set of discussions and blog posts and other things, but do really think about how are you classifying data? What are you putting into these agents? Can you use synthetic training data whenever possible? How do you really think about your input and output guardrails of these agents so that because they know their job, it's easy to define guardrails of what they should be doing along the way? Really think about this because you don't want to make a misstep in this area and end up putting a bunch of sensitive data in that maybe shares information or leverages information that it shouldn't. So be really thoughtful about that. All right, so to recap, we have six recommendations. Formalize your agent roles, know your system, keep your agents simple. That's the opposite of that trap of creating the blob. Put your standard operating procedures into those agents, start them on human review, and then keep training them, but in a safe way. So this is all the stuff that we've learned over the last 18 to 24 months of using these agents. We've gotten a tremendous amount of benefit inside of Red Canary, and all of the investigations we do, we can find more threats. We find them faster. We're getting more context and more data for both our team and our users because of what these things do. They're super powerful. I hope this has been really helpful for you to understand all the power that you can get with this and make it a little less of a black box where you're trying to figure out how does this so-called magic AI actually work. With that, I always like to start with a little bit of a what's next. It's just some way that you can think about how do I actually go put this into action. So, as someone who really loves to build things, here's my recommendation. On Monday, get your team together, have a little lunch or some type of collab session, and just say, hey, let's go talk about processes we're doing, decisions we're having to make. Like, what are some parts of our day to day that I think AI might be able to make a good impact? Build a little effort impact chart and figure out what might be an interesting job or two that AI might be able to help us with. And then by the end of next week, go pick one of those jobs. Pick something that you think, okay, let's go try this. And let's really then document what is the workflow we do inside that job, right? You got to know your system. So, how do we go pull all that information together and document it out in a little checklist? And then have your goal be by the end of this month, go build your first agent. Give it that job, make it clearly understand what task it's supposed to do, document that workflow of how you've been doing that job into the agent, and then go run it. See what happens. Look at how well of a job it does, give it more feedback, and embed more of that in to get more outputs there. If you're wondering how to get started, you can look around at a variety of open source AI agent tools if your organization hasn't picked one yet. Ones that we've played with that are on the simpler side of things. If you're a Python leaning organization, there's Crew AI. If you use more Ruby code, there's a Shopify framework that are all designed to be pretty approachable agent frameworks. And then there's lots more out there, depending on whether you want to operate inside Claude or other frameworks you might have. So hopefully this is a helpful understanding of how you can get started, demystify a lot of this. And so Wanted to share all of these lessons that we've learned. It's been great having you all here today. I'm super excited to jump into your questions. We've gotten a ton of those. We're going to dive into Q&A, both from the questions that we had pre-submitted from you all and things that we've seen coming along the way. So with that, I want to introduce Jimmy Assel, who's going to be joining with me as we tackle some of those questions. Welcome, Jimmy.
All right. Hey, Brian. Thank you for that awesome intro, awesome content. Before we dive into the questions that everyone has submitted, I just wanted to give a quick overview, a quick intro on my team and how we fit in and how we provide these agentic services to Red Canary. So we have a formal data science team inside of Red Canary, and we handle both classical machine learning model building, monitoring, maintaining, and we also build these sort of agentic systems that help support Red Canary's security operations center. And so, we're the team building, maintaining the infrastructure and tooling for that, but we're also the team sort of pushing what's next. We're pushing the limits on what's possible with these agents. And so just a really quick plug, as part of this webinar, you'll get some content. We just released some open source tooling where we actually are giving out a framework of how to automatically sleuth through OS query data and help you do automated forensics analysis. And all of that code is free and open source. And it'll really help you kind of dive in and sort of contextualize how we use these things, how we break these problems apart, and what Brian was talking about in that webinar. And we look forward to seeing what you can build with it. So, Brian, you want to start with some questions?
Yeah, I think if we look at the first topic here, it's all about AI at Red Canary, how we're using this in the SOC. Let's maybe start with the last question here, Jimmy. You want to talk a little bit about how these agents support the existing Red Canary team, the detection engineers, the intelligence team, and just talk about sort of what that partnership looks like first?
Yeah, that's a great question. This is actually one of the fun questions that was submitted in to answer. Like I said, our team is sort of in that Venn diagram between security operations and engineering, and we do sit in the middle there. And I see that the sort of supporting the talent pool of an already existing great pool of people, where it's sort of like education and automation are the two kind of big areas, right? And so how I look at this is I like to think of these agents as interceptor agents, where they're sort of sitting in the middle of our SOC workflows, and they're helping sort of take a signal in and do a bunch of that legwork, querying, summarizing data, retrieving data, and building that case, extracting features, maybe making some lightweight decisions, and then helping our detection engineers sort of come up to speed faster and orient themselves faster when they're doing those detections and not doing a lot of that busy work. But I would also say that we have a lot of our detection engineers, threat hunters, threat intelligence folks going off and just building things. My team provides inference as a service. We provide that infrastructure for people to go off and build cool things. We have folks building MCP toolings to automate, query building in the different EDRs or identity tools. We have teams building MCP tools to help us automatically tune detectors and give us lists of detectors that are coming in. And so, Brian, what I see is it's really helping automate like that rote busy work task. And then the other flip side of it is where you see sort of some indirect sort of up leveling of the team is that a detection engineer will get an event that an agent analyzed and go, oh, I didn't realize that conditional access worked that way. Look at it. When I dig into this data, the agent went and pulled this, and I saw a couple of failed logons, and then they successfully logged on, and I didn't realize that error code meant this, right? And so it's like they're learning on the job based on the analysis and outputs that they're seeing from the agent. So it's a few different areas. It's exciting to see live.
Yeah, I think, Jimmy, what really stands out hearing you talk about it that way is we've had these principles around how do you bring software into the SOC since we started doing this at Red Canary. And this philosophy we've had is software engineer is a job, but software engineering is a skill. And we think it's a really useful skill for a lot of people in the SOC to have in various levels. And so we've tried to make it possible through frameworks and through systems to democratize the ability for the SOC to write their own software to go solve their own problems. And I think we've done something very similar through the frameworks and the training and the principles that your team has done, where we say, hey, AI or agent engineer might be a job, but agentic engineering is a skill that anybody can do. And if you can make it simple enough and most straightforward enough for people, then it really allows you to get way more power out of this than what would happen if one specialized expert team only did it by themselves.
Yeah, I agree. And the other thing I would add there is we're even seeing it internally. The role of a detection engineer is changing, and it's changing industry wide, not just at Red Canary, right? And so we now have detection automation engineers where their whole job, right, is to build and monitor, maintain the sort of security operations know-how inside of our agents. And so, yeah, you're absolutely right. Like it's evolving, and folks are taking those tried and true cultural practices that we had and applying it here.
So I think this kind of fits into one of these questions. Let's maybe transition to a question Bob asked here, which is where does the agent interaction actually happen for us? Is it in a platform? Is it some custom agent? The answer is it's a lot of different areas depending on the use case. And I can say, one of those is some agent interaction, some agent execution is happening inside the SaaS console that you might interact with at Red Canary. It's just built into those workflows and processes. Then there are some other agents that are getting executed as part of a behind the scenes data flow pipeline set of automation that's running kind of behind the scenes inside Red Canary's platform. And then, Jimmy, maybe you can talk about if you're an intelligence engineer or if you're trying to run these. I mean, those teams they're running the agents sort of themselves, triggered off of scripts, locally on, I guess, run locally from their systems with all the models and stuff up in our private cloud, right?
Yeah, exactly. We're using a combination of Python notebooks, Claude Code, and MCP tooling to kind of do things interactively on their desktop. Yep, absolutely.
Yeah. So I think let's talk. There's maybe two questions I'll weave together here around the first one on this slide. Is this human plus AI balance? Is it normal? Is it unique? We also got a question around what about these native agentic AI SOCs? You know, I think maybe if I start thinking about our approach here, the Red Canary approach is always one that's built on pragmatism. We are trying to solve a very real problem of how do you go get through all of this huge mountain of data? How do you find the threats? And how do you get through it as quickly as possible with the highest accuracy as possible? And so for us, I think we don't feel like we are stuck inside a box where we have to pick, do I want to be human only? Do I want to be agentic only? We don't have to chase the marketing terms around, hey, we're building the world's fully autonomous SOC or agentic SOC. Our focus has always been the outcome. It's served us really well to focus on that outcome of keeping our customers safe and protected from big security incidents. And then we just work backward and use this tech however it helps us to get there. And so I think that actually is quite unique from other security vendors who generally feel like they have to pick one path or the other. But it's probably very similar to what you would find inside some of the super sophisticated SOC teams who are doing this themselves.
Yeah.
Uh, Jimmy, let's talk about trust. When you think, we talked earlier about the recommendations of putting them into probation, testing
Yep.
their alignment over time. How do you think about that trust decision of when do you let agents make decisions themselves?
Yeah. This is, I think, one of the hardest questions, both, I would say, objectively and like in a deterministic kind of way. It's a really hard one. I would say, Brian, first of all, would I trust AI in a high stake situation? No, I would not. And to sort of be even more clear, I wouldn't trust like any software automated system in a high stake situation. Like I still want a human, you know, validating with their peers whether or not decisions should be made in those high stakes situations, because that's sort of the tried and true method. And I'm not saying that AI won't ever get to that place, but it's certainly I would not trust that today. We have a lot of experience under our belt on these, but on the trust side of it, I know you talked about this in the talk that you just gave, but I think the whole point of building these agents is building that trust on your customers. Who's consuming the output on the other end of these? And so you can't just build these and then ship them and be done. These agents require care and feeding. They require monitoring. They require sort of that feedback loop from humans. And so as you get that feedback, as you get those reps under your belt for the agents that are in production, that is when you can start to sort of trust them more, right? And the analogy that I like to say is like you hire the intern and you give them the easy tasks first, and then you measure them, right? That's what you just talked about. We're going to measure what happens. And then they prove themselves, as they learn new skills, as they sit side saddle with somebody else, they progress in their skill set and their ability to solve different problems. And I would treat AI agents and tooling the exact same way. And that's how that trust gets built over time.
That's great advice. One of the questions in here from Brian was around, do we have a managed service that develops these agents for our customers? We don't. We use these agents internally as we go do that ourselves. So we are the developer. I describe it almost as we're often customer number one for them. Or if we're developing an agent that is something that you would interact with directly inside the platform, it's not designed for a specific customer. It's designed for a specific job that we're trying to do or support on your behalf. All right, let's talk about specific implementations on how do we implement this AI. One of the questions here is where do these agents, like where do the models run? Are they something like, do we have this running around on a bunch of people's direct laptops? Are they out in Foundry or AWS's equivalent of that? How do you manage all of these models, Jimmy? Because your team is not just using one, you're using purpose-selected models, right?
That's right. We use cheaper models, more expensive models, reasoning models, depending on the job to be done. Another plug for that the talk that Adam put in here. But we talk about that in the open source tooling. You can see how that's being used. But all of our models we use through Azure. We use Azure OpenAI models in production for a variety of different families of OpenAI models. We do not use any open source models. The reason why we use Azure is they're a great partner. They scale really, really well. They give you a lot of quota. They have the capacity to serve our needs for inference for our agents. I would just recommend that if you're going out and trying to pick, a hyperscaler or a provider of models, if it's free, it's not free. They're harvesting your data, and so do not do that. You should look at the terms and services. You should trust the vendor that you're working with. All of the major hyperscalers, Google, Amazon, Microsoft, all have a really great stable of models and proven families with terms of service that protect your data. And so just really be wary of that piece and make sure that they're not using your data and training things. It should be very much like kept private. You manage your models. You manage your own capacity. You manage who has access to your endpoints. That is a really important piece when you're using these models from a hyperscaler.
So, Jimmy, can you then talk about, okay, so if we trust the model and we're running it in a trusted location, now I get to the point where I talk about trusting some of the outputs that come from it. And, you've been on the other side of some of the reviews I've done where we'll look at what comes from some of these models or systems we produce where they do a 10 out of 10 job of writing that threat recommendation paragraph 7 times in a row. And then the eighth time, it looks like my 10-year-old maybe wrote it and he doesn't know that much about security. How has your team focused on the implementation of the rest of the SDLC or the AI LC of how do you test these? What sort of unit testing frameworks do you have? Like, how do you make sure you get predictable and consistent results?
Yeah, that's a great question, Brian. So, like you said, we do traditional software engineering practices. So, what we do is we will build an agent for production. And of course, we do tons of back testing. We do a lot of reviews with internal teams to make sure what the output that's coming out of these agents is satisfactory. And then what we'll do is we'll actually mint those outputs as like a gold master. Like, hey, when this agent runs, this is what it should always look like, right? And so then we actually have software in our pipelines when we ship this code or we update models where we can update a model anytime we want. And what will happen is that code will run, it will run the CI, and then it will look at the output. And we use other machine learning practices where we'll say, hey, how semantically similar is the new response that came out from whether it was an agent instruction change or a model change to the gold master? If it's 90% or more similar, then we're good, right? If it's less than that, it will fail the test. And that doesn't mean that the output is bad. It means that it requires human review because oftentimes the output will be better, but the wording isn't semantically similar to match sort of what we're doing. And this is a really good way to have deterministic measurement of the outputs. We also have feedback in our product where customers can, thumbs up, thumbs down, say something's on target or off target. And that is a whole other feedback loop where, to Brian's point, sometimes, a data retrieval might bring back incomplete data because we're still ingesting something, right? And so the agent's going to give you like a half complete answer. And so that gives us the opportunity to say, at what point in time was this feedback given? Where was the source of that? Where did the data come from? What was the context the agent was giving? And it really helps us grade and understand how did that answer happen? Let's not ever let it happen again. How do we make tests to recreate this so that we can test that in the future? And again, it all just comes back to sort of that SDLC. It's just the intermediate technology is spitting out tokens that you need to validate versus like, did this unit test pass this response back correctly?
And I think that's an awesome example of living out where we talked about use AI for things it's good at. One of the things we know is we're using these agents many times to generate text, which is really difficult programmatically normally to say, does that text match what I want? And so you're pretty meta there, right? You're saying, I'm actually going to use AI to go read the outputs of my agent, check it against what I'm expecting to get as a way to calculate that similarity, not on a per character basis, but an overall basis, right? Like what,
That's
it's
yeah,
a great
that's right.
example of using AI for the right use cases.
Yeah, and you touched on another sort of topic was we use transformers, not large language models, but Google transformers called BERT. It's a family of transformers. They're on Hugging Face. You can check them out. But we also use this concept that you sort of touched upon called LLM as a judge. And you might think, what does that mean? And it's actually the concept of you look at the output of something, and then you have a separate agent with very specific instructions to say, this output should only have 3 bullet points. It should only mention these words. It should never mention these words. And so you have an LLM judging the output of another LLM, and that might seem like meta in a weird way, but it's actually the industry accepted way for most teams of how they're checking the output of these agents in the real world.
And it also solves this really nice human use case of if humans are judging your work or your agent's work, you get emotional because you don't like that you're getting critiques on that. But if you make the LLM be a judge, it's kind of like the long-standing joke of if you tell Alexa to go tell your kids to brush your teeth, your kids might be less annoyed than if you tell them to brush your teeth all the time.
Yeah.
All right. So we have all of this data. It is, from the Red Canary perspective, we've got 1,000+ customers whose different data, sits inside of our systems. We know that one of the big traps to avoid is crossing streams and using the wrong data in the wrong ways. There's all sorts of examples of companies who have been inappropriately handling data. How are you and your team and the Red Canary team, like, how do you keep each customer's data secure and isolated appropriately?
Yeah, it's a great question. So this is one of the things internally in Red Canary Engineering that we take very seriously. It's like the number one thing that we're always on the lookout for when we're designing new code, when we're reviewing new code. But if you're thinking of trying to solve this problem while you're building AI agents, it's not you're not going to be successful. What do I mean by that? This is a fundamental sort of data segmentation and access like zero trust problem that all you should always have, right? So how do you access sensitive data? How do you access customer data? What are the sort of existing tools that you have to use, right? And if your company or your organization hasn't matured or doesn't have a process for that, you definitely need to start there before you start to build those agents, right? And so we're building on top of an already existing robust sort of customer segmentation platform that Brian can tell you a lot more about.
Yeah, so from the pure software side, this is where in our world the tenancy model is super important, where we say, every one of our customers might have one or more tenant inside Red Canary. Those are very logically separated, and that data gets tagged through a number of systems. And then there are additional layers of security checks and verification to say, okay, if this job or service is running inside the context of this tenant, it is prevented from accessing data outside of that tenant. It also will check things and sort of fingerprint things along the way to make sure that it's all touching the appropriate data. And I think that, Jimmy, is what you all have carried forward throughout the agentic framework as well, too. Is that right?
Yeah, that's exactly right, Brian. Yep. And then I would add to that that there's a sort of a couple other players. So that's talking about like data retrieval, this concept of retrieval augmented generation RAG. That's a core architectural pattern that we use with our agents. But then there's inference. How do you protect inference? Well, it's just in time. It's just in memory. So you do that inference on the LLM, and then that memory sits on wherever GPU and whatever data center, and then it goes away, right? And so there's never data crossing streams there. And then sort of another principle that we have with our agents is caching. So we will cache data for a very small window of time, but we don't let them persist state through that cache because that's really where some of those risks can come in of crossing streams. And then, we talk about these agents and the autonomy. I like to talk about agency. How much agency do you give these agents? No pun intended. And the thing there is that like you have these new technologies like MCP, or you have fully autonomous swarms of agents. That's really where you can get in trouble with crossing streams or getting data intertwined with each other, because no matter how much instructions you put into these agents, they are none the wiser. They don't understand those concepts. And you have to go back to first principles and software engineering of only giving these agents access to data just in time, just for the jobs they need to do. And that's it.
No. All right, so let's talk about ROI. Next big category of questions we had gotten here. So the first one here is, how can AI enhance threat detection and response in the SOC without increasing false positives? I'll live out the answer to this through some of the principles we talked about earlier, which is the first thing that we're going to think about on that front is we are not going to try and solve all of those problems with one set of AI or agents. That would be an example of trying to create the blob, like we talked about. And so we'll look at that, and you can look at using AI. Our advice would be think about those as discrete, different problems you're trying to solve for, right? There is a job to go enhance threat detection. There's actually probably two jobs inside of there. One of the jobs is how do I go find more potential threats? Then the second job is how do I go enhance, maybe enrich some of that threat detection? Those are two different jobs. I might write, in those two categories, I might have multiple agents whose job is to go do that. Then I think about, okay, increase, how do I do it without increasing the false positive rate? Well, that's a different job, right? That's a triage job or an investigation job. I might write a different set of agents who's focused on that. And so the answer, like we could talk a lot. I really would advise like listen to the talk that Jimmy had done, what he just talked about of this big sort of kit we just put out online that goes into more detail about that, because we could spend hours talking about all the ways you can do more finding of threats, more enrichment of threats, a bunch of baselining of typical behavior. There's a ton of Red Canary blogs all about that. But the real principle and what I'd go back to is think about those as separate, discrete jobs and use agents specifically for them. All right.
Yeah.
Jimmy, when you think about this from a cost perspective, I think what actually, like, it's not one of the questions specifically here, but since we're talking about ROI, a whole bunch of companies, software vendors have taken their customers through this whiplash of, I'm going to use AI in a bunch of places. And then, oh my goodness, it cost me a ton of money. I have to pull back on it. Could you just talk like how do you and your team think about how much money you're willing to invest from an AI perspective, how you determine the ROI like that? Like how are you a sort of a good steward of your team's budgets on that front? And then I can maybe talk about what does that do from an overall like product ROI perspective.
Yeah, that's a really good question. So, you could spend a lot of money really quickly in these cloud providers, especially with cybersecurity data, where it's so voluminous, and you can just sort of call these agents anytime you want to help you out. And so, I think one of the first places to do, right, is understand, like to Brian, the point you literally just made was, which jobs are we trying to do in the SOC? Which processes are we trying to automate? Which things take up the most amount of human time and cognitive load, something that you doesn't show up, in a monetary value, but it's still cost savings in my mind of my people don't have to do that anymore. And so those are the things to focus on first. And I would just say, like, if there's a process that's taking me 30 minutes to do, and it's just paper pushing busy work, those rote tasks, can I offload some of that 30-minute task and reduce it to like a 2-minute task, right? That is sort of at the high level what we're trying to do to show the ROI using AI. So cool. I'll continue to pull the thread. If I can automate a forensics analysis looking through dozens and dozens and dozens of OS query output, and I can do that in minutes for like 30 cents instead of having a human do that over a 30-minute period for whatever they're working at rate, right? And so that's one of the areas where we sort of look at this within the SOC of the cost benefit of the job to be done and the human savings versus how much is it costing us in cloud compute costs of goods sold. I would also say on like the runaway costs where you can really quickly spend money on inference is, again, it comes back to that agency. We don't let our agents just magically go off and do inference and go on loops and things like that. We don't have like interactive chatbots where people could just sit there and chat and chew through credits or quota that we have, right? And so we have a sort of product controls in place that will allow us to do that. And then finally, one of the secrets to all of this is there should be some TTL or time to live or caching in the inference that you're making. Because a lot of times in cybersecurity, right, you get a lot of duplicate alerts and things. And so if alert comes in from Jimmy and it's the exact same GUID and everything, and a timestamp has changed, and the AI has already analyzed that from 5 minutes ago, why do I need to go run it all again, right? And then I think you talk about this a lot in your talk, Brian, is that one of the things that we found really early on was we built these fully autonomous agents and we let them do all the things they would want to do. And what we realized when we sat back and looked at them was like, well, every time I call the identity investigation agent, the agent reasons and says, I need to go query identity data. Well, I don't need to make an LLM call to do that. I could just replace that with regular code. And now I'm saving money there. And so one of the things that we found in ROI and cost savings when implementing these is go build a fully autonomous thing and then start to figure out what stuff can you replace with deterministic code that gets you the same outcomes to save on cost.
That's a great point. I think it is really unique when you think about if you're using agents to solve a specific job for you. When you talk about that framework you did of how much time am I going to save, how much is it going to cost me to execute it, you also talked about how much time is it going to cost me to build it. I'm sure somebody could find it and go paste it in the channel here, but there's that old XKCD, right? That says, how often do you have to run this task? How long does it take? And then it calculates for you, here's how much time it actually makes sense mathematically to spend time automating it, right? Because we know human nature, we're pretty terrible at estimating ROIs naturally, right? We often get sucked into, I really need to automate that thing that I need to do for 5 minutes every month, and I'm happy to spend an entire weekend doing it. That doesn't make any sense, right? And so you can apply those same principles, like you said, to how you build agents.
Yep.
Do you think so? One of the questions we have here is I'm planning to use agentic AI to automate SOC analyses. I'm trying to figure out how to make a smart decision from a build versus buy perspective. Jimmy, do you think should everybody go build an agent theirself to try and solve one problem first so they can get an estimation of how long it would take them or their team to sort of inform them? Or how would you advise people make that decision?
Yeah. If you have the technical know-how or your team, you have folks on your team that have the technical know-how, I would dip my toe into that first. Pick a dead simple task and just see what it takes. I think oftentimes what I've seen on my own team even across Red Canary is a few of those people will hey, go check this out. I don't know how this works. I don't understand this technology. I know, but just go figure it out. There's so much content and training out there. And then everyone has that aha moment where they hit go, the agent comes back, and you're like, oh my God, it was that easy, right? Or it was that hard. This is such a hard problem. And I think, Brian, what you were sort of getting at, and I agree with, is that see how just look at what it takes to build these things. And if these are really complicated things, yeah, there's a lot of SaaS software that is out there to make this easier. Maybe there's intermediate things you can purchase, COTS software you can purchase to accelerate your agent development, or maybe you just go and buy it all to help you to plug those gaps, right? But I do think it would make you a better overall knowledgeable person in this area if you're even going to buy that stuff, if you start to understand just some of the fundamental things and the cost behind it.
So I think that maybe, let's wrap here a little bit on overall cost savings. What is this going to do? Sort of what are the outcomes we get? What I can share is the Red Canary experience in that, our overall mission, like we talked about, is keep our customers from getting distracted due to big security incidents, right? So it's all focused on how do we prevent our customers from having big security problems. What we've found from a cost savings perspective is through this agentic AI, we are detecting way more threats than we could before. We are investigating them meaningfully faster than we could. We are also doing better investigations because we're pulling together so much more data so quickly than we could do if we waited for a human to pull that data together. And I think if you look at that from a financial perspective, what it means is we have been able to really control the cost growth of doing detection and response as we bring in way more data and use way more detection analytics and look for a much higher, number of adversaries and techniques they're using. And so what you'd see is the number and quality of outputs we're producing has grown probably exponentially, while the amount of cost that we incur to do it, both on the human and the AI and overall software side, is not growing nearly as quickly. We've been able to keep that relatively, it's not exactly flat. And with how much cyber salaries grow on the human side, it's never going to be flat. But we've been able to maintain it at a controllable level, which is why I think people often talk about any form of technology tends to be deflationary overall, right? And we've seen that here as well too.
Well put.
All right, Jimmy, in the last two questions, the one, the big one, I think what everyone is really wanting to hear from us and why they joined today was they want to know, do you think agentic AI is likely to take us into a future world war? Because that was one of the questions we had beforehand, and we know we are the nation state experts on this, right?
Yeah, we were giggling about this, and I couldn't tell you one way or the other. Who knows?
I think when we look at all of these questions around the fear of AI, my encouragement to anyone who's really worried about this is sub the word software in for AI and ask yourself the same question over the last several decades of this. Did software replace workers? Absolutely. Did it help us and create a whole bunch of new jobs? You bet. Will AI replace some jobs in the future? Absolutely. Will it also create a whole bunch of new jobs in the future as well too? Absolutely. Right? It's the great benefit of this software, and I think the approach we always take is let's get the best we can from it and use it to improve all of our lives. We've gotten great benefits from that so far. We're going to keep getting more of that in the future, and it's something to, really like use the power for good, use AI for good things, make your team's lives better, make your customers' lives better, for those of you who provide those services. That's the way to do it. Awesome. Hey, thank you everyone for joining today. Really hope this was helpful, both walking through our recommendations, traps to avoid. I'll plug one more time at the end. You'll get the recording of this shortly hereafter. Go to the Red Canary blog, look at the AI topics there. There's a bunch of information you can learn more. Send us your questions you have or any way we can help your teams. Really appreciate getting to share all of this with you today. Thanks for joining us.
Thank you.